Hi, I'm Mira, and this is my quiz tutorial. So the problem I'm doing is chapter 18, problem 66 in the book, and the problem gives us the diagram shown here with location C in the middle, and then a circle around it, and then a semicircle, two straight wires on the left and right, and a half loop on the bottom. And it asks for us to find the net magnetic field at location C, which is here. So the first thing I did was just kind of map out how the current is flowing. So as you can see in both the outer half circle, semicircles, and straight wires, it's running clockwise. And also in that inner circle, the smaller one, is also running clockwise. Then what I did was divide what we have into several different parts. So the first part is the semicircle on the top, the small one. The second part is a semicircle that's large on the bottom. And the third part is the loop overall, which is that small circle that surrounds location C. And then an important thing to note is that the straight wires on both the left and right side of location C contribute no magnetic field at location C. Because if we were to do the cross product of the unit vector R and our L vector for dl, then the cross product would eliminate all of the components x, y, and z, giving us a product of 0. So the straight wires have no magnetic field. Therefore, the net magnetic field is equal to the magnetic field of 1, 2, and parts 3. So the equation I started off with is the equation for a loop, and this equation is the approximation equation that approximates that location z is much, much greater than location r. However, in this scenario, the location z is equal to the radius, either the big radius here of the big half circles, or the small radius, which applies to the loop and the small semicircle. So we end up with this formula, which is mu over 4 pi equals times 2 current pi over r, either being big R or little r, depending on the radius. So now B net is the first part here, which is a half loop using the big radius, the second half loop, the semicircle, which has a small radius, and the third part, which is our loop that also has a small radius. And when we factor out all of our common factors, we get this as our product for the net field. However, we're not done because we have to find the direction, which will give us our net magnetic field in component form. So, as denoted earlier, the current I is clockwise. So if we take our right hand and move it in a clockwise motion, as we move down, you'll notice that your thumb is pointing into the page. Into the page is in the negative z direction because our thumb is the direction of the magnetic field, and our thumb is what's pointing into the page or in the negative z direction. Therefore, our total answer is the net magnetic field is equal to 0, 0, and then negative of what this magnitude value is here.